Hello, I'm Etto. Today I will interview the high-power rocketry team of the University of Limerick. Could you please introduce yourselves?
I'm Dara. I'm leading the team. I'm also team leader for our Mach-24 project. I've a load of my team members here today. We started as UL Aeronautical Society about 2 years ago. Myself, Sean also were part of the initial 5 who started that society, and launching in EuRoC was like our key goal at the time, but none of us had any rocketry experience at the time. And over the last 2 years, we've kind of built that up from low-powered rockets to the point now where we're launching at Mach-24, hopefully in July. And last semester, we decided that the high-powered rocketry deserved to be its own kind of separate thing to the rest of the society, which kind of does a few more social and casual events. And we formed HiPR, so high-powered rocketry. And we started recruiting properly and really organising ourselves. We brought in some brilliant people who were really good project managers like Dervla, and really made the team a bit more professional and started looking for proper sponsors. And here we are trying to make our name in the rocketry teams of Europe and eventually get to EuRoC. So hopefully next year or so we'll be launching in EuRoC. But first Mach-24. We also have our first high-powered launch coming soon with Shinna, which if anyone's seen our social media, they'll also have seen that rocket.
When do you want to go to EuRoC?
Well, at the moment we're developing a rocket for Mach-24, and the brief for Mach-24 is very similar to EuRoC. So I think if resources allow it, we'll be able to quite easily build off that rocket to a EuRoC rocket. So if we have the resources available and everything is going well, hopefully it'll be a 2024 entry, and 100% will be in EuRoC in 2025. So we just need to see when the EuRoC requirements come out. I think they come out about March, and read those and see how well set up we are for those. We don't want to stretch ourselves too thin.
Could you talk a bit about your university and how it is to study in it?
Yeah, so we're all part of the University of Limerick in Limerick, Ireland. A mixture of bachelor's degrees and masters. We come from a variety of different courses. We have a lot of people doing aeronautical engineering in the group. A bunch of people doing AI and other coding-based courses, which is brilliant for the electronics and the more complicated parts that some of us wouldn't really know, doing the kind of the structures of the aeronautical. Yeah, it's a brand kind of a newish thing. So HiPR split off from EuRoC pretty recently, which was set up under UL's clubs and societies, which has been, it's a big thing over here in terms of like how much it costs. In Ireland, we're pretty lucky that it doesn't cost an arm and a leg like over in America. So it's about my fees would be about $3,500 for a year, €3,500, and living over here is relatively cheap for a big city, but it depends on if you can find the accommodation. At the minute, we don't really have any scholarships or grants if you're looking at the HiPR or joining this team. If you want to get a scholarship or grant, you'd have to be in certain sports. But a lot of people come to this university because of the aeronautical. There's not many space or even aerospace courses in Ireland. So it's a big attraction of the University of Limerick.
I think Sean and Joe have also travelled abroad with during their studies. So I want to talk a little bit about that.
Hi, I'm Sean. I'm also part of the team. I'm also one of the founding members of EuRoC a couple of years ago when we founded the society. And then last year, I got the opportunity to do a study abroad in the United States. I went to Embry-Riddle Aeronautical University in Daytona, Florida. That was a great experience at such a high quality school, which actually just last week, a student project from that school designed and manufactured a camera, which was on board the lander, which just landed. So it kind of just goes to show how far students can go in terms of rocketry and space. And I think that's what we strive for. I would really recommend doing an Erasmus just for anyone who gets the opportunity. It really teaches you a lot about yourself, independence, and you get to see a lot more culture around the world.
What are your job opportunities you have after university?
We get a lot of outreach to companies and people in like the European Space Agency and these kind of really big space giants in Europe, which is brilliant. So in terms of job opportunities, we already have kind of people out there. We're reaching out to people who are alumni or people who've qualified in these companies. And hopefully, obviously this is pretty new, so we don't know so far, but hopefully some of us will go on to work for said companies, because it's a brilliant thing for us to be doing here, to be building rockets, and it's the amount of attention we're getting from these people, from these companies who are looking at us and going, wow, these guys are doing really, really well. Yeah, it's looking really, really good. Talk to, like, in terms of networking, we've done a lot of talking to even other rocketry teams. So we were talking to EttoCraft. We did a Q&A session with them. They're a Portuguese team. We have contacts to launch the rockets. We have contacts in the military, and also we're talking to a lot of other small teams in Ireland who are trying to start up and get off the ground. So, in terms of reaching out and making connections, it's a brilliant thing to be in.
What's the experimental rocketry community like in your country?
Kind of rocketry in Ireland kind of has a bit of a rocky history in that there was a big scene with the Irish Rocketry Society there in the last kind of 20 years or so. And there's definitely some projects happening in the 90s and the early 2000s. But then there was kind of some complications with launch sites and things, and that kind of died off for a bit. But now in kind of the last, I'd say 2 or 3 years, you've got a lot of kind of college teams like ourselves are kind of picking up the mantle. So, you know, you've got ourselves in Limerick. There's Aerospace in Dublin. They're kind of a lot of universities from Dublin. Then there's the University of Galway. There's SETU in Carlow. They've all got kind of different rocketry activities of different degrees. You know, some of them are thinking competitions. Some of them are going the R&D side and doing, you know, more experimental things. And then others are kind of more just looking at putting it as part of their coursework. So I think especially in the last kind of year or so, there's been a lot of startups and things. And hopefully in the next 5 years, you know, there'll be a lot of exciting things happening in Ireland. And hopefully there will pop up more kind of a space industry here now when a lot of that kicks off.
Yeah, like even last week, we were only talking to someone who was a previous like UL alumni who was building liquid rocket engines in UL in like the 90s. So there is a history of this kind of stuff in Ireland. It just never really took hold and took a root. Like those people would build that rocket engine and then graduate and it'd just be forgotten about. And then someone else would kind of do something similar a couple of years later and be forgotten about. So we're really hoping that we can set something up that's kind of permanent now.
What are your team's goals?
Build a good space in UL for people who are interested in launching rockets and even just any kind of space engineering to have somewhere to go to. Like Oren touched on, this is one of the only colleges in Ireland where you can actually do aeronautical engineering or anything to do with aerospace. So we do get a lot of people in UL who are interested in space, and up until now, you have no opportunity to really like build a rocket or go do kind of big student engineering projects like this and indulge in those space activities. So we want to really give people an opportunity, because then they can go on and say, I want to work in the space industry, and do interviews and say I worked on a rocket in UL. And also it's a great time. So short term, we're launching in Mach-24. We also have 2 smaller projects at the moment. We have Shinna, which is our first high-powered rocket, which are finished, and we're just waiting to get that launched. Like Oren said, we're launching with the Defence Forces. We have Shinna 2, which is Jamie's team, which is a group of first years who are just learning how to start high-powered rocketry and get their hands on that. Oren's leading a R&D team where they're going to try and do a TVC control low-powered rocket, which is something that is really advanced for us, but I think it'll be something interesting and it's fun as well. And kind of just in the future, we can use that technology maybe on a larger EuRoC rocket. And then going into the long-term future, of course, we're going to launch in EuRoC. And I think one thing everyone on our team is really like wants to do, even though it'll probably be by the time it happens, I'll be graduated, is start building our own rocket engines and making propulsion a thing in UL.
Do you plan on making liquid rocket engines in the future?
Plan is maybe a strong word for it, because we haven't really put any proper like anything set in stone yet. But it's 100% something that we started sending out some feelers for at the moment and seeing like, how do you go about doing that in UL? What are the facilities? What kind of budget would we need to make that happen? How would health and safety kick back on us? Where would we have the space? Those kind of things. And I think it's something that like any person who's serious about building rockets or going launching a EuRoC does think about liquids, maybe hybrids, but definitely liquids, and making those a reality.
How do you recruit new members for your team?
Preparation in early November, and we did a big recruitment drive for kind of engineering people as we were starting to prepare to do our 3 projects that are ongoing right now. By doing that, we were able to recruit a large amount of people. We did that through, it was just a Microsoft form, and then we reviewed everyone's applications and then sort of sorted them into teams where we felt their expertise would be best fitted. So now, right now, we're not accepting any engineering recruits, but we are looking for kind of business, marketing, and public relations people, as that's something we've kind of found is lacking.
What can members learn from being in your team?
Joining our team and you're in UL, you first off learn an awful lot about rocketry. Don't really have an awful lot of space-specific modules or courses within our aeronautical engineering course or the other real courses in UL. So you're really getting your first chance of learning about rocket dynamics. Hopefully they'll get to learn about propulsion in the future, but that's not something we offer at the moment. If you're working on, say, our electronics team right now, you're really getting hands-on in terms of like working on our flight computers, the electronics for our ejection system, which we'll kind of touch on later. Our Payload right now is very unique. You'll be learning about AI if you're working on our Payload. You're learning about structures. For an awful lot of people who are in first year or second year, they're actually getting to learn about stuff before they get to do it in university or in their actual coursework. It just makes it something that's attractive for people to do. So it's not just like, doesn't mean that they're just putting time into this and not getting anything out of it. They know that, okay, I'm in first and I spent the last 6 months working on this Rocketry project, but I know that the knowledge I've gotten in this will make a module in 2 years' time that much easier because I've already spent time rubbing shoulders with fourth years and third years who've done this kind of work. And also I think myself, I've learned an awful lot about working in a team, just coordinating with people and like project management and making sure things kind of run smoothly. And even I suppose Sean could like back me up on this, in setting up this and working on it, you learn an awful lot just about organization and having to speak to people and how to like just communicate with external sources, talking to sponsorships, potential sponsors, communicating with university about funding. And it's just, it's a wide range of engineering skills. I think that really help to complement what you learn in UL.
Doing any sort of project alongside your engineering degree is so worth it. Like Dara was saying, you gain a lot more skills when you're actually applying them in practice in something like this. So that's something that's been really worth it. And as well as the engineering skills, as Sarah just mentioned, the team building, the teamwork skills that come from it as well are very important.
Could you tell me something about how you design your rocket?
So this is an interest. We have 2 rockets now. Well, one's built and one's in the process of being developed. And I think our first one, Shinna, had a much more tumultuous design process in comparison to the Mach-24. But I think Sean can give a really nice description of how well we've worked for Mach-24 now.
When we were kind of developing it, we were looking at what were our requirements, which were our target apogee, as well as the deployment of the CANSAT. So we set those down as our first requirements. And then we sort of looked at what are the major components. So we have the nose cone, the payload itself, the payload deployment, the actual airframe structure, the motor, the fins, etc. And then we kind of broke down each of them into what concepts we could do. So what nose cone shapes, different diameters, different lengths, airframe diameters, materials. And what we did was we used a lot of design matrices where we weighted all of the pros and cons of each of these into a numbered system, which allowed us to score each design concept. And then we kind of narrowed down our choice of different materials, sizing, and shape. So yeah, that's how we kind of led the design process for Mach-24. Before that, for doing Shinna, it was a bit different because we were a lot less experienced in terms of rocketry. So using kind of the high-powered rocketry textbook, we sort of looked at what were the things that go into it. That's where we kind of learned about our options before we got to evaluate them.
How do you test and measure the performance of your rocket?
Well, I think this is something that's kind of ahead of us now because we still have to launch Shinna and we have to launch Mach-24 or Mach-24 rocket, of course. But on Shinna, Sean Burke, actually, you can talk a lot about how we're measuring, or we actually have a CANSAT in Shinna. I think that's something we didn't mention. I'm actually just going to leave Sean Burke talk about that. That's his brainchild in Dervla as well. They really know what's going on in Shinna's CANSAT.
We're going to use the flight computer really to gather data on the rocket. It'll tell us things like velocity and deceleration and altitude and stuff like that. The egg timer can store this information on a little EEPROM chip it has on it. And then once the rocket is on the ground and we recover the rocket, we can just download that data onto our phone and then, use it to gauge how successful our mission was, That's kind of it really. That's as far as it goes. And it'll be the same for the Mach-24 rocket as well, because that'll also have the egg timer on it.
How do you promote your team?
So I guess our main sort of point of outreach and PR is our LinkedIn. We try to make posts pretty regularly. They tend to be things like updates on how we're getting on in our meetings, updates on the sort of build status, and Shinna was a big one. So they're kind of the main ones. We're trying to sort of get more outreach within the college, and then as well as outreaching to sort of companies and people for sponsorship. So they would be our main points of contacts. And then we also have an Instagram, which would be similar enough to the LinkedIn.
Could you talk a bit about the UK Mach-24 competition?
Yeah, so we heard about the Mach-24 competition, and obviously we want to do EuRoC. Like that's our overall goal. But EuRoC is expensive. It's in Portugal, and that adds to transportation costs. And the requirements are, although they're very similar, the EuRoC. I'm sure you've read the EuRoC requirements before. They're a load of pages of requirements and what you exactly have to do. Mach-24 is a bit more lax. So like it's build a rocket to 3,000 meters, carry a 1 kg CANSAT to 3,000 meters as well. Although in Mach-24 it is harder in that we have to deploy that CANSAT at the top of our, or it's not even at our apogee, but at some stage during the flight, which adds more complexity. But we have it's a bit easier for us to get over there first off because it's in Scotland from Ireland. That's not an expensive flight in terms of transporting the rocket parts and just the people. There's also a higher limit on the amount of people you can bring. You can only bring 9 people to that competition. I suppose I think the EuRoC teams are like can be 30 big. I know certain teams have been very small, but and as well as that, the actual just entry costs are just lower. So he said, we're a new team. We want to do something as close to EuRoC as possible, but we're going to go to do Mach-24. So 3,000 meters with a 1 kg payload that has to be deployed, and both of those have to be recovered. And then there's a whole raft of other kind of specific requirements. Most of them are centered around safety, you know, like how well our fins can resist a certain deflection, a certain test we have to prove that we've done before we're allowed to launch a rocket on site. Yeah, that's the challenge for us really, is to design something that improves or like gives us a knowledge jump from what we've done on Shinna to what we're going to do on our Mach-24 rocket. Like Sean, aren't we using a lot of fiberglass and carbon fiber? We're taking advantage of some of the facilities in UL. In comparison to Shinna, we're using this material called blue tube, which is kind of common for like hobby rocketists and hobby rocketeers in the US maybe, and we got recommended that by one of our mentors from the Irish Rocketry Society. But yeah, we're going for more exotic materials that will, the kind of materials we'll be using when we go launch in EuRoC, you know?
We are really taking steps up in terms of our capabilities, what we can do and what we want to do. So we're looking at using a lot of composite materials, so carbon fiber for the lower section of fuselage, as well as fiberglass for the upper section. The reason we're using fiberglass over carbon fiber for that part is the interference with radio waves. Well, the interference radio waves you find in carbon fiber and metal fuselages, but the fiberglass will allow those radio waves to pass through, lower interference.
Stepping forward, even John Burke, you forgot about the CANSAT in Dervla. You can talk about the CANSAT we have in Shinna. So like between Shinna and Mach-24, one of the differences is that because Shinna was always designed to be like, this is a stepping stone to a EuRoC rocket, we were like, we have to bring a CANSAT in it. That was something that was really important to us. So now we're doing Mach-24. Like, Sean, you can say, I'll let you talk about your CANSAT, Adam, and Sean, you can talk about the Shinna one, and Adam, you can tell us about what's going on in Mach-24. So now we're at Mach-24, we're like, okay, we have a proper CANSAT, and like, the difference between that CANSAT and what we have in Shinna, you know, and then some stage at EuRoC, we're going to have an even more advanced CANSAT. So it's a whole system step jump in terms of what we're doing in Mach-24.
Yeah, so the CANSAT on the Shinna rocket, I would liken it to sort of like Sputnik satellite, you know, we're kind of just launching it up, seeing if we can receive the data from it, and that'll do us really. It's just a proof of concept like this, to see if we can do it, you know, and if we can't do it, learn from the mistakes and learn from why we couldn't do it, you know. Adam, would you like to talk about the fancier CANSAT in Mach-24?
So in our Mach-24 competition rocket, we're carrying AgriSat, which is our 1 kilo payload. And the goal for this payload is to obviously descend and recover safely, but to intelligently map out the land below. So part of the Mach-24 competition is to have a sustainable mission and goal. So AgriSat is running AgriNet, which is one of our new sort of AI developments. And what it'll be able to do is understand the plant health and the irrigation paths of the scene below and intelligently stitch them together while using only low-cost hardware. We don't have the money for a very fancy scanner.
You mentioned the blue tube. What exactly is it?
Blue tube, if you've ever seen like phenolic that people would use in their like high-powered rockets, blue tube, I think the official word name for it is like vulcanized cellulite. So it's like this hard material. It's like, it's kind of like cardboard material, but it's much more pliable than say phenolic, but it's much stiffer than cardboard, and it's really tough. Like tough is actually the best word to describe it. Like, and you can use it as if you were using cardboard or wood. Like those are the kind of safety requirements. So you're not talking about putting on masks and stuff to cut them like you would with fiberglass or carbon fiber. But it's a really, really strong material. We've all had to import it in from the US, but it was an easy material for us to get started. You know, it's like our Shinna rocket is just a monocoque design. Is 2 tubes with your central kind of E-bay middle and your payload at the top. We 3D printed our nose cone. So being able to just like get a really robust, easy to work with material that we can't really break too easily in trying to learn how to build a high-powered rocket just suited us very well for us, and it's relatively low cost as well for what it is, you know. But I know there's some really, really cool rockets that have been built out there using blue tube, and I think Jamie, you're using blue tube again for Shinna 2, aren't you?
Yeah, we are. We're just going to use blue tube for Shinna 2 as well, because it's kind of to develop our experience in building rockets. And so going off kind of a new material and working with that would kind of be, I think, just a challenge, slightly too high for us, because, you know, a lot of us are in first year. We've never built a rocket before. So yeah, we're going to go with blue tube for that, and hopefully have it go the same as Shinna.
What are your goals for the Mach-24 competition?
So I suppose we're trying to launch a rocket is the first thing. After that, we want to deploy a payload. And if all that goes well, we want to recover both of them. But like we said, one of the main things we're trying to do is develop our own experience in terms of like rocketry. high-powered rocketry, competition rocketry specifically. Like we could be launching 1 million rockets at home if you wanted to, big ones like as big as Mach-24, but going to a competition and meeting new people, the operations of that, kind of being stringent on terms of like timelines we have to hit with Mach-24, PDRs, CDRs. It does give us that experience that when we do go to EuRoC, whether it's this year or next year, we kind of have that knowledge built in. We have at the moment we've just submitted a PDR. We actually recently got feedback on that. In the next month or so, we'll be putting our CDR to paper, which will mean a design freeze. And in order to do that, we will have to start testing. I think we're very close to testing. One of our main goals, I think, with Mach-24 and how it differs with China as well. I'm saying Mach-24, so I'm kind of referring to EuRoC as Mach-24 because it doesn't have a name yet, but it's to develop a non-explosive deployment device purely because black powder is not easy to get in Ireland. And we want to be able to test our rocket and especially our deployment system repeatedly, relatively easy, instead of having to go reach out to someone who has a license to handle black powder and meet on a certain day and test it. If we develop a non-explosive deployment device, we can test it 1 million times in our lab and know that it works and be confident that on the day our rocket our parachutes will deploy and we'll be able to recover our rocket successfully. And hopefully building from that in Mach-24, all our future rockets will use this non-explosive device. Does anyone else want to add to that there in terms of what we're doing? I think, Adam, what we're doing on our payload is fairly ambitious.
It's a very kind of new thing. So we're building off some research that NVIDIA released. So they have it's called a general adversarial network for turning one image into a different image. And we're building off that model. And the goal is really to replace the need for using a very high cost spectral camera. And so we want to train a model that can turn the images from our normal camera into a synthetic version of something similar, but in near infrared. So yeah, it is a pretty ambitious project. And obviously all that data has to be stitched together afterwards. So other sensors we're using along with the camera, like the IMU and the GPS, are going to be really important there.
Could you give more information about your rocket, like how much it costs?
Budget at the moment, I think we've about $1,000 budgeted just for propulsion in terms of we have to buy our casings because China's using a disposable, single-use commercial off-the-shelf motor. Mach-24 is going to be using a reload case, so we have to buy that case and the motor. It's going to cost us in and around $1,000, I think. Derval, how much are we spending on electronics between the payload bay, the eBay for deployment?
I think the payload was coming in at just under 300, and I think the eBay was just under €250. So around €550 combined.
And then we've been really lucky then that, in terms of the material for the body, Sean, you're distracting me there with your camera. But in terms of the material for the body, we're very lucky that UL are actually helping us out an awful lot in terms of 3D printing parts and kind of the parts of doing the carbon fiber and fiberglass layups. So that shouldn't really be much of a cost on top of the rest of it. But like we said, we're a new team, so we're trying to build this rocket without not relying on, not saying we're not relying on sponsorship, but we want to keep our costs low because we know that we can't budget for a really expensive rocket and expect someone else to pay for it. We have to kind of work within our means. And I think it's very achievable. We've done an awful lot of work now and gotten very far without much money. So yeah, I think that kind of brings us back to around 1,500, maybe $2,000 probably by the time it's all said and done. I say it would be a good estimate.
How much of the rockets do you build yourself and how much do you outsource to sponsors or buy?
Yeah, so the majority of the rocket will be manufactured ourselves. If we talk from the bottom up, fins should be made of, well, we haven't actually fully decided on that, but our fuselage structure will be carbon fiber, which we'll be using the facilities in the University of Limerick to lay up ourselves, as well as then the fiberglass upper stage, which we'll be using a 3D printed mold and then vacuum infusing the fiberglass and the resin onto that. The nose cone will be 3D printed, and a lot of the internal bulkheads and such will be laser cut. So we have the laser cut facilities also in the University of Limerick. And then the final assembly will be all completed by us. So realistically, we are getting very hands-on. I think we're drawing on a lot of experience from another module that myself and a couple of the other members here are doing, which is Design, Build, Fly. Which is a module we do in fourth year where we design, build and fly a small controlled aircraft. So that's a lot of hands-on manufacturing as well. And from that experience, we're able to transfer it over to the rocketry. And so we'll try and get as hands-on as we can just to build our own experience in terms of a lot of things.
Yeah, I think that one of the things we are buying in is, say, we're using our motor mount is going to be blue tube again. We have experience of that from China. Parachutes, we're not making our own parachutes. Weaving our own shock cords or quick links or eye bolts are kind of hardware. Obviously, we're buying in screws and bolts. But yeah, I think we are trying to get as hands-on as possible. I think for a lot of us, it is an opportunity to get hands-on. Not everyone's going to be doing that DBF module that Sean mentioned. So we don't want to just design a rocket and send it off and have parts come back and put them together like a big mechano set. We want to, for better or for worse, we want to try and build as much of this rocket ourselves.
When do you plan to make your own engines instead of using commercial ones?
Yeah, this is a long-term plan. That's, like I said earlier, that's not something we've fully nailed down yet, but I think it's something we'd really like to start as soon as possible, even if that's like, say, next semester, starting on paper and building up from there. I think it was important to us to get experience with rocketry first and launching at competitions before we started building an engine for ourselves. But like I said, it's been done before in UL, and I think it's something we, like, everyone who gets involved in rocketry wants to do it. So I think starting next year is our plan. We're going to start really seriously looking at propulsion systems next semester.
Do you want to make a normal solid-fueled rocket candy engine, or do you want to try out something else?
I think we're going to try either hybrid or liquid. I think they're the safer options in terms of you've kind of two relatively inert chemicals that you can store safely, rather than having to go mixing something like rocket candy propellant, where like the minute you mix your sorbitol or sugar in with your potassium, it's a kind of live solid there where you're kind of worried about sparks and shock ignition. But so I think probably liquid or hybrid. I think hybrid is the route a lot of people are taking now as their first step, is in terms of just you can make 3D print an ABS, some motor grain, or just melt it out of paraffin wax and then just get your nitrous oxide or your liquid oxygen plumbing equipment and kind of get going there. But I think if you want to do something serious, it would be a case of going to liquids. But I think that's more of that's a question for next year, and it's a question for the next generation of people, because like I'm a fourth year now, so I think, Jamie, what do you want to do next? What route do you want to take for propulsion?
I don't know if I'm at the level to even know half of what to do with propulsion, but no, I think by the time I get to Dara's stage in fourth year, I'd love to have some sort of propulsion system coming out of UL by the time I graduate. So maybe that'll be the long-term plan by the time I get there.
Yeah, I suppose liquid first, Etto, if you want a clear answer.
For your own trail, does the Mach-24 competition provide it, or do you build it yourself?
Off the top of my head, I can't remember if it's a 1010, 1515, but yeah, Mach-24 are going to be supplying the launch rail for us. However, we do have to make our own ground station. I think Dervla and Adam, you've kind of been working away at that now at the moment, haven't you?
Yeah, in terms of ground station, we're just going to use a simple Raspberry Pi Pico microcontroller and sort of have it connected to a LCD screen, and then the sort of telemetry modules we're planning on using. Just kind of simple, and we're hopefully going to get it connected up to a website to be able to sort of post up live stats about the rocket.
How do you want to make your recovery system?
I'm Joe, I'm the lead recovery systems. And so essentially we'll be making it just two parachutes. We'll have a drogue, obviously, and then we'll have a main. So initially, once we hit apogee, we'll separate the rocket in the middle, essentially, and release a small parachute that will essentially just stop us from accelerating too fast, and will give us a lower terminal velocity, and then we'll release the main chute, so to reduce our final velocity when we hit the ground. But essentially it's just, there's a tough balance in trying to slow the rocket down, but then also not slowing it down too much so that the wind starts just pushing us completely off course, and the rocket ending up in a different country. So there is a bit of a balance and some calculations in trying to figure out how to balance it, essentially just trying to make both parachutes work together. And it's important because as Dara said before, and also Sean, in terms of retrieving the telemetry and receiving our entire rocket itself, we don't want anything to break, essentially. We are launching it up super high, we're going 3 kilometers up into the air, but we want it all back as well. And so all of the telemetry, all the data about the flight is super important for us to try and kind of move forward with our rockets. And so making sure it comes back down safe is a big priority. But like Dara was saying earlier as well, in terms of actually letting the parachute out of the rocket itself, instead of using the black powder is kind of generally used for high-powered rocketry, we've gone for a new system, which is just a spring that will push the rocket apart. And so it's quite new. There'll be a lot of testing involved. At the moment, it is just kind of, this is what we're going to do. And once we have the CDR in, we can kind of, as we get closer to the competition, we'll be able to just test and test and test. And that is the benefit of the spring itself, because we can just reload it and then try and see if it pushes the rocket together apart. And we can do different tests, like in a wind tunnel or even on top of a car, to try and simulate the speeds that it will be going at apogee, and what it needs to be able to withstand. But yeah,
What is the payload of your rockets?
So the experiment we're doing, AgriSat, is that we want to find out how feasible the land below is for farmland and general agriculture. And so we're going to be able to pick up. And so this project has kind of exited the proof of concept stage. So we have sort of a working version 1, and we can read in, without using any big expensive sensors, how much chlorophyll is being reflected from the plants. So that's a good scale of how healthy they are. We can also figure out where the water is in the scene below. And this is all part of an open source contribution we're doing. The payload's actually running on one of our other open source projects, which is the relay system, which is a pretty elegant solution for running all of these different scientific experiments on a Raspberry Pi.
Do you know Kerbal space program?
Yeah, it's a game I would have played a good couple of years ago. I learned quite a lot about sort of the overall layout of a rocket, as well as then the operational side of things, how to manage different launches and different things. From him, I learned a lot about orbital mechanics, which was kind of cool when I then got to do an orbital mechanics course on my Erasmus, applying those things which I learned through Kerbal. So I do think Kerbal is a good place to start if you're looking to get into rocketry.
Does your team have announcement or dream?
Suppose just to launch rockets. I think we're all just no. I suppose we've said everything we kind of have at the moment. Like I said, for us at the moment is just existing and being able to go to these competitions. For us is our dream. That's, like I said, when me and Sean started this society 2 years ago, we wanted to go to EuRoC, and that just looks like something that's more and more likely. It's been a long path here. So I suppose that our announcement is that we're here, and that we're launching rockets from UL in Limerick, and that there's rocketry happening in Ireland. We're not the only team in Ireland, and we aim to someday I'll look back and ULAS HiPR or some kind of rocketry this group in Ireland will still be, or group in Limerick will just be one group out of many in Ireland who are launching rockets, and there'll be a rocketry team in every university in Ireland.
Do you have any advice to young rocketeers?
I think, because even I know me personally anyway, kind of a year ago almost, I didn't really think of space as just a thing you could do. I was like, it's this kind of like, this foreign kind of world with all these genius engineers and scientists. It's like, oh, that's something other people do. People from Ireland don't do that thing. It just doesn't happen. And then, now I'm sitting here and we're talking about a rocketry team and all the projects we're working on. We've got to talk to people from ESA and, all these really intelligent and smart people who've got to do all these cool projects. So a lot of it is kind of, I know it's kind of stereotypical, but it's like if you really want to do something and you're interested in it, there are people out there who are interested in it and are doing it. So, just make the effort, go do the research, and you will find those people out there, and you all will get to do something pretty cool, hopefully, by the end of it.
What are your favorite space movies or YouTubers?
Interstellar.
It's definitely The Martian.
No, Interstellar for me, I think. Does Star Wars count? We say Star
Yeah.
Wars, or is that that doesn't count, does it?
I feel like that's going to cause another argument.
Interstellar or Gravity? Gravity. Have you seen Gravity?
Not Gravity.
Ad Astra is a great one.
No, not Gravity. No.
Ad Astra is a great one. That's like Gravity, but
Undecided, in other words.
Undecided, yeah.
Undecided, yeah.
Yeah, I don't know. Who's like Scott Manley fans? I'm a Everyday Astronaut fan here. Like I kind of quite.
I
like his
love
video.
that guy as well.
Yeah.
Very good.
I'd say Real Engineering is my go-to because he went to UL.
Oh yeah, that's a good shout out actually. Yeah.
Yeah.
Irish guy
anyway-
too.
Irish
Yeah.
guy. Who else? Everyday Astronaut, Scott Manley. Does Kyrgyzstan count? Yeah, of course, yeah. We're doing a TVC rocket. Yeah, BPS space is a huge influence. Jamie, you're a big Kyrgyzstan fan. I know that. Does he count in space? He does a lot of videos on aliens.
Oh, they do so much. They're what got me into space in the first place. Kyrgyzstan, best space YouTuber. They're so good.
Do you have any questions for me?
What are your own long-term goals? We see you do a lot of. You're big into rocketry, and you're also into like electronics. I saw you were building a Tesla chambers. Yeah, Tesla coil. Sorry, yeah. Like, do you want to build rockets or do you want to work with electronics, or are you just still figuring that out?
I think a bit of both. I think that when I think that I've already made enough smoke with rocket candy, I'll do a bit of electronics to change. But something I would like to do one day is try to make a liquid rocket engine.
Yeah.
I mean, I have tried, and depending on the definition of success, I may have succeeded or probably not. But I would like to have to be able to make like a good rocket engine.
Have you launched many like low-powered rockets yourself, or smaller rockets?
Yeah, I've launched like tens of homemade rocket candy rockets.
Yeah. So that's the start. Like it takes time and figuring. So you're starting like way earlier, I think, than anyone on our team has started. So like by the time you're in college and doing stuff, like it'll be. It's really cool following your LinkedIn and seeing just all the different projects you're up to. What are you working on now? What's like your main goal at the moment?
Now I'm with electronics. I'm working on a project which I'm calling the Magic Wand. And it's basically a handheld high voltage power supply. Probably one of the hardest projects I have made. In theory, it's quite simple, but making everything so small is quite hard, actually. It reminds me in EuRoC 2022, there was the TVN rocket, which it was a liquid fueled rocket, which weighed only 13 kilograms. It was tiny.
Jeez. That's impressive. Like, you're doing electronics. I know, Sean, you probably understand more about the electronics side of things, but like, because I don't really know, we don't do much electronics in our, I think we've one module in first year where we basically attach some resistors Martin Hayes attaching some resistors in series and measuring the resistance afterwards. Like, but I think high voltage sounds scary.
You have a hard time. What you tend to do with it, like?
It's a handheld high voltage device. If you want to have high voltage handy, then you just pull it out and it's handheld.
Yeah. I suppose, are you having problems with the voltage kind of drop? You mentioned you wanted to make it small.
Yeah.
Is it like your own printed PCB is it that you're using to make it small, and surface mount components and things like that?
Yeah, so I am using SMD transit MOSFETs for the ZVS. It's quite simple, really. There is a ZVS, and then there is a voltage multiplier. So it's actually quite simple. And there is a high voltage transformer, which I saw with some adult TV.
Salvaging electronics is always a good way to start. Do you do much coding as well then for those kind of electronics projects? And
no, I don't really get into coding.
You have to start. Python's a good place to start. I think I only know a bit of Python and maybe some MATLAB from university as well. But like, I think adding electronics and then adding the coding bit to it, like, really opens up a whole new world of stuff, you know. I know, like, Dervla loves coding. That's kind of her passion in life. Any tips in terms of coding, Dervla, like how you got started with that?
Just like start with Python. You kind of keep going. Raspberry Pi organization of really good resources. It's like a good mix of hands-on projects with electronics plus getting the code side of it involved.
I did do a bit of programming, but like very little with Arduino. However, once I started to understand how to make logic with transistors, I ended up doing that. Apparently, I prefer making my own logic circuits instead of programming.
Sure, we're using Arduino on our CANSAT for Shina, aren't we, Sean? Like, that's like, it's something you can put into a rocket and launch it.
Yeah, anything you could do anything you want in Arduino, really, that you could with building a circuit. Just the handy thing about an Arduino is you can use it for communicating with a ground station one day, and the next you can make it blink an LED. Like, you know, they're very, very versatile machines, we'll say, actually. So a circuit is kind of only single purpose. That's what I love about it. I'm really big into microcontrollers now. I'm doing electronic and computer engineering, so I kind of do like a bit of both, a bit of programming and a bit of circuit design. But I definitely would prefer, and you probably will too, I definitely do prefer using a microcontroller. Like, it really does, you know, simplify things down the lot, because the programming of them isn't even that hard really either, and you can kind of bang out a few programs very fast as well, and really try your hand at everything, like, and kind of see how things work. So yeah, that's kind of all I have to say on that.
No, I mean, I think that a microcontroller is better in some cases, whilst making your own like oscillators or logic circuits is better in other cases. I mean, if you want like a compact amplifier, then probably the Arduino isn't the best solution.
You're dead right. You're dead right, in fairness, yeah. Well, no, that's just my opinion on it anyway. But you are dead right.
And like, I don't know, if you want to use it to control your payload in a rocket, then it's probably quite a bit simpler than designing your own very big logic circuit.
Well, I think what we're using in the rocket at the moment, I mentioned it earlier, it's an egg timer quantum, it's called. We buy it off this guy called Chris Serving in America. I don't know if you've heard of him, egg timer rocketry.
I have heard of the egg timer. It's very common at EuRoC.
We're trying to use those. You buy them in components, let's say. He has the PCB, the components all there. You just have to kind of put it together, and it's definitely handier. Like, if I was to go and design that myself, like, it would take a month of Sundays, you know, it'd take ages to design all that and test it. So it's quite nice having it.
Well, saying that, Sean, as well, I think going forward, we're going to have to... 2 seconds there, no, wait. I'll show you something I was messing around with during the summer. It didn't come out. Yeah. I think the egg timer quantum or quasar I think we have is...
Quantum.
Like, that's using an 8266 chip. That's after going out of camera. Yeah, you know, like, if you wanted to start doing stuff there, like, where you're like, it seems like you like working on the hardware side of things. I'm by no means an electrical engineer, and in fact, this circuit doesn't really work well, which stands a testament to that. But like, you can start off and get a microcontroller like that. That's an 8266, and that's the same chip that's on our flight computer. And I think this is most of the, like, I have a barometer here and an IMU, and that's what we're buying on a night timer, and we're spending more money on it. So like what Sean Burke says there about being hard to put together, he's just whining because he had to do the soldering on that like 2 months ago, and it took him an hour, or not an hour, like 6 hours to do.
Took
so
6 hours. Yeah.
you can definitely go about building it. So like even you're talking there about making your own hardware. Maybe there's someday they're like you set up your own company and you're making your own hardware from the ground up specifically for space, you know, space hardened hardware for stuff. But definitely I think Arduino is a good way to start anyway for us. Some people who aren't as as technically advanced in that kind of space.
Another useful thing is breadboards, of course, for circuits. Many times it's much better to use a breadboard than soldering. But when you're doing power electronics, then you risk melting the breadboard, as I have done many times. It's actually interesting how the traces start glowing red. But
when you're doing your liquid rocket engine, actually, could you actually tell me more about that? Because I'm always interested to hear about people building their own liquid rocket engines. It's something I think I'd like to do myself, and even like HiPR would like to do themselves going forward.
I wouldn't recommend copying my liquid rocket engine. I mean, there are a couple of reasons why it's not really good for a well-made rocket. First, I used just air as an oxidizer, and that changes quite a bit of things during design, mostly for the injectors. Also, if you use air, you have much lower operating temperatures than if you use oxygen or nitrous oxide. Also, it just wasn't well made. I didn't really spend enough time to try to optimize it. However, I would like in future to try to make it better, like using more metal and less tape and cardboard.
But you had tape and cardboard rocket. Did it just burn when you started igniting it, or what happened?
Well, I always say it worked for 5 seconds. Then it started melting.
Expendable, I suppose. What did you say your fuel was? So liquid oxygen, or like air, just as your oxidizer, and what was your fuel?
Yeah, so I decided in the end to use ethanol as the fuel, just 90% rubbing alcohol. It's quite good as a fuel. Probably would have been much easier to use like propane or butane, because ethanol does not want to mix with air. It does not like mixing. If you use propane or butane, it is much simpler.
So that those would be your changes. It'd be like either change to like nitrous oxide and like maybe use ethanol again. Would it be? And like, did you make? How much of it was cardboard, and like, did you have any metal in it?
In the first prototypes, I had a 3D printed nozzle, like a PVC tube or sometimes a cardboard tube. But in like the later tests, I used a metal nozzle and a metal tube. But the injector was 3D printed.
I think one of the things I've kind of been looking into a small bit in terms of rocketry, and Jay is another person in our society who's really interested in propulsion. Building a nozzle, like, or building those parts out of metal, like, all the solutions we see to that are like use a lathe to get your nozzle shape. How did you go about getting your nozzle out of metal? Was it lathed, or was it just cobbled together with parts you found? Or
I asked someone to use a lathe for me.
Oh, cool. Okay, so I was hoping you'd say that you didn't use the lathe and you had some other method of doing it, but
well, there are other methods, of course. You can cast it.
Or are you talking maybe about like an aluminium cast yourself at home?
Yeah, you can do an aluminium cast. Like the Astra Bremen team, they made many casts out of aluminium. It's not that hard, actually.
Actually, that's a good. I hadn't thought of that, actually. Yeah.
Yeah. So what you want to do is probably do like a green sand casting, or maybe lost wax casting, lost foam casting, something like this. Maybe lost wax casting would be the best.
Yeah, because I suppose you could like 3D print your mold, melt your wax in there, and then I suppose you need your mold to be something more heat resistant than 3D printed plastic, I suppose. But
yeah, so lost wax casting, what you do, you make the shape you want out of wax. You can like 3D print a mold, put wax inside, and that's it. And then once you have your wax nozzle, you like put it in plaster concrete with a hole, and then you just put it in the oven once it's dry, so that all the wax melts and goes out. Once you have your molten aluminum ready, you put it in the hole and you make your nozzle. Oh, and to remove it from the plaster, you break it with a hammer.
That's cool. I'll look into that last week. Yeah. Thanks, Editor. I've learned something now after that today.
If you want like more advice about how to melt aluminum, you want a clay graphite crucible or a crucible. You can either get like an electric furnace, or you can just use a blowtorch, like a big blowtorch.
Yeah, that's very cool. Thanks, Etto. I think we'll definitely endorse you on LinkedIn after the interview, 100%. Been very enjoyable the past hour or so, and I've definitely learned something there anyway in the last bit. Food for thought. I suppose they say thank you anyway on behalf of ULAS HiPR for taking the time to interview us.
Yeah. And thank you for coming. to be interviewed.
We'll definitely see. Hopefully, we'll see you at a EuRoC very soon as well.
Thank you.
Thanks, Etto.
Thank you. Bye bye.
Yeah.
Bye bye.
Thank you.
Thanks, Ed.
Thank you very
Bye.
much. Goodbye.
Thank you.
Thanks.
Bye bye.